afternoon, everyone. Really lucky to be the lucky last. I know that Rob has prepared lots of questions for me. I'm preparing for the lucky last presentation. So I'll go straight to the journey and how I come to artificial intelligence. I have a very, let's say, multidisciplinary background. I did my undergraduate on information management, information system in the School of Computer Science at the University of Finance, Economics, and Law. And my favorite subjects, including quite a lot of statistics, open research, mathematics, and many of them. Then in my master, I studied the management science and engineering that in the College of Management. Then I usually do courses in the I do the many courses. So I could be doing a project with master students in business management or human resource management in the morning. In the afternoon, we're doing project with students from civil engineering, or in the evening, I could take a course from the School for Computer Science again. So that end my evening course on data mining and machine learning is my favorite course. So I decided to do a project using artificial intelligence techniques for portfolio selection in the stock market. That's why then I come to New Zealand in 2010 and to do my PhD in artificial intelligence. And among was my supervisor. He was also the nominator of my Real Society fellow application. Then my academic career, I finished my PhD and started postdoc. And you can see that I think actually 5 years and a couple of months to become a professor. So that's according to some people, they say it's probably the fastest. They have no. So in 2021, I become a professor. And that's also make me to be the first female professor in engineering. And now we're probably the only female professor in Faculty of Engineering at Victoria University of Wellington. That also makes me to be the first professor in artificial intelligence, because Mom was a professor, but he was a professor of computer science, so he's an old guy. Then I had, in all my career, I have received a lot of funding and very active in applied fundings. And also have been working as a deputy program director and deputy head school. That when I work with my colleagues to develop New Zealand's very first postgraduate programs in artificial intelligence and the very first undergraduate programs in artificial intelligence. And then I was also, we also work together, established the Center for Data Science and AI. So I'm not the director, Mong is the director, and I'm working with him on all these projects. And then internationally, and sometimes I was talking to Everett this morning, I feel like I was more known in international community than rather than New Zealand community. Hopefully from today, now we can know more of you. So a lot of leadership roles, and more important, I really enjoy my role as a woman engineer and also woman in data science in New Zealand. Was also internationally recognized that every 2 years they got a fellow. So 2022 was a fellow of engineering, then 2024 fellow of IEEE. That was for more the international organization. And now I'm here, and I was also highly cited researchers in New Zealand in computer science, big IT. There are only two. Then one's Mong and one's myself, and for all the 3 years. And if you want to compare in 2023 or 2024, there are 6 in Australia. They have so many universities. And then if I want to looking at how AI, the growth, and this image is generated by ChatGPT, by OpenAI, so I could cut it because in the second there, below the other half of the history doesn't seem to be very accurate, so I only choose the top ones. So then, so there are many milestones. I kind of was born in the winter of AI, in the later part of AI, and my research in AI, start from where big data and deep learning foundations before deep learning actually starts. After deep learning starts, after all the computing hardware devices, so there has been so much progress in AI, and sometimes I really don't know how to draw this line after 2020 because there were so many things happens. And I'm looking at all those terms, like every couple of months there's a new term comes. Then my student will come to me and say, Bing, do you know this thing? I say, don't tell me new word, tell me how it works. This generative agentic and the word model and all sorts of those models. But sometimes that Mon will say, when people bring the multimodal AI to him, he thought that's just a multimedia many years ago. Why people keep creating new names for this old technology inside. So then sometimes I also don't know what is artificial intelligence because every 5 or 10 years they have a new term. And people 2 or 3 years ago, people will say that's large language model, and then you will say AI is generative AI. And later on now, I'm sure people will say that's agentic AI. And later on there will be maybe tomorrow there will be a new AI term about that. And what we are doing, this is more like not only myself, the whole team, the center doing. So we are working on quite a number of, we're working in many areas of AI, and those areas, so like the image and deep learning, multi-objective learning, and feature selection, interpretable AI, and that's the one that we can claim that we have international leadership. And we also collaborating, we have many collaborators within New Zealand and overseas on all those application areas. We continue working on that. And those are the new terms that we added in. So for myself, that for the ones like I have been leading this including feature selection and including automatic design of deep neural network, deep learning models. And this is also actually my most highly cited paper. And also two of my masters are on these two topics. And also, if you're looking at so one of the paper like we wrote, and this is has been on the top 5 most popular papers in the Journal of High-Probability Transaction on Evolution Computation, which is one of the very few top journals, and it has over 30 years of history, and that has been always a very popular paper. And I also have some other most cited that don't have the screenshot. And we also have a book, which is the first book on generative programming for image classification. And that is kind of the third master, which is actually the PI. I was a co-PI, and the PI was Yingbi, was one of our students. And then she left, so I also take over from the co-PI to become a PI. So there are 3 areas, and having a 3 masters to support, which is really great. At the same time, that so those are the fundamental research. We also working on quite a lot of applications. For example, the area I talk about feature selection. If you map it to this medical or biology domain, we're working on biomarker selection, which is, for example, from hundreds of thousands of 10,000 of features or variables. You select the most important ones, and our method are able to, for example, select from 700 the 5 true biomarkers, and we were also able to find some other combinations that achieved a 100% accuracy, but the domain expert did not really think about this is another solution for the problem. And we also have some, not only selecting from the original data, we also having we call the feature construction, which is from the original low level, what we call low level, for example, here, each of the variable, you have no way to find a cut point to separate the blue and the red. With a simple combination that we are able to find a perfect cut to separate these 2 different classes. And we also having some other skin cancer detection that's we're able to provide a solution, and that's the consistent with the dermatologist how they can diagnose the skin cancer. And we also having some in primary industry applications. For example, we're doing these muscle farms. We're able to detect each individual boys in the farm, detect the line, giving the ID, detect the buoyancy level, and also reconstruct a 3D model of the whole farm. And later on, our worker is able to have the GPS location of every single boy in the farm. And we're also working on a lot of other big seafood agriculture and industry with many collaborators from Planet Food and Corson Institute as well. And we're also working on trees. And I'll show you a lot of tree-based models. And we're also working on New Zealand tree and Singapore trees and to detect the individual tree clone and species. And also working with Canterbury University, we detect the trees and also using a drone and cut the branches of the tree. We also work with Antarctica Research Center to create models that can actually to predict ice sheet melting and modeling in Antarctica region. So there has been lots of work. I've shown you those are the tree-based models because we believe on whatever you create, a solution should be understandable. And we also have research and solutions that are using a very deep neural network model with billions of parameters. And we can do that. We can also do it, provide a simple solution to be interpretable. And I run out of time, and I would like to thank everyone, thanks the Real Society. You know, also the work has been supported by students and colleagues and collaborators. And also, you know, my family, my husband, who also has a PhD in AI, and we talk about AI at home as well. And we're always seeking for collaborations, you know, all area disciplinary collaborations. So thank you, everybody.